Hello everyone, welcome to Homework Help. If you find the video useful, please subscribe to the channel. In this video, we'll use implicit differentiation to solve the problem. As per the problem, show that xy equals 1 and x squared minus y squared equals 1 intersect at right angles. We are given the equation of two curves and we have to prove that these two curves intersect each other at right angles. For this problem, we have to use the concept that when two curves intersect each other at right angles, the tangent to these two curves at the point of intersection also intersect at right angles. This is a very important concept we need to understand and memorize. Tangent lines are straight lines. If two lines intersect at right angles, that means the lines are perpendicular to each other, and two lines are perpendicular to each other if their slopes are negative reciprocal to each other. There's another important concept we need to understand and memorize. So we have to find the slope of tangents to the two curves represented by the given equations. For that, we have to find dy over dx for these two equations. Let's start with the first equation, xy equals 1. We have to find the derivative of all terms in this equation with respect to x. The first term is xy. Term xy is made up of two functions x and y that are being multiplied. So we have to use product rule to find the derivative of xy. As per the product rule, we start with the derivative of the first function. The derivative of x with respect to x is 1 times the second function plus the first function x times the derivative of the second function. The derivative of y with respect to x is dy over dx. 1 is a constant, so its derivative is equal to 0. We can simplify this equation. 1 times y is y. We have to isolate dy over dx in this equation. So we should move the y term to the right side of the equation. It will become negative y. Next, we should divide both sides by x. I get dy over dx equals negative y over x. This is the expression for slope of tangent to the curve xy equals 1. Now we can find dy over dx for the second given equation. We should find the derivative of all terms in this equation with respect to x. Let's start with the first term, x squared. The derivative of x squared with respect to x is 2x. We have to use power rule. We move the exponent 2 to the front of the term and subtract 1 from 2. We can use chain rule to find the derivative of y squared with respect to x. The term y squared has the inner function y and the outer function the exponent 2. As per chain rule, we start with the derivative of the outer function. We should use the power rule. We should move the exponent 2 to the front of the term and subtract 1 from 2 in the exponent times the derivative of the inner function y. The derivative of y with respect to x is dy over dx. 1 is a constant, its derivative is equal to 0. Now we can simplify this equation. In the exponent, 2 minus 1 is 1, x to the power 1 is just x. The same goes for y. We have to isolate dy over dx in this equation, so we should move the term 2x to the right side of the equation and it will become negative 2x. Next, we should divide both sides by negative 2y. the negative 2's cancel each other out and we are left with just x over y. So dy over dx is equal to x over y. This is the expression for slope of tangent to the second equation. Next, we should compare the expressions for dy over dx for the two given equations. For the first equation, we got negative y over x, and the second equation, we got x over y. These two expressions are negative reciprocal of each other. That means if we flip one of these two fractions and change the sign on it, we get the other fraction. This proves that the tangent to these two curves intersect at right angles at the point of intersection. If we use the same x and y values in the dy over dx expressions we got for the two given equations, we will get the slopes that are negative reciprocal of each other. Since the tangents intersect at right angles, therefore the curves also intersect at right angles. So this is how we can explain our answer. So these are the steps you have to keep in mind to solve a problem like this one. I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.